Welcome to Solaredge's webinar on optimizing your rooftop installation. We're going to talk about the best practices that we've learned to get your crews as profitable as possible and on to the next job as quickly as possible. Joining me today is Cameron Stewart, who has over a dozen years of PV experience, and he's going to be using that experience to help you out. If you're in the US market, you know that this market is heating up. This market is growing fast, and in 2016, the key to your profitability is going to be jobs, jobs, jobs. So with no further ado, we're going to kick right in.
Thanks, Mike. If you've used Solaredge before, then you know our power optimizers are connected one module per optimizer in the residential application. And then we have our optimizers that are wired in series that run down to our inverter. So this webinar is strictly geared towards the guys working on the roof. I want you to be successful, and I want you to get off that roof as quickly as possible. So the first step is your mechanical attachment of the optimizer to the racking system. While we're making that mechanical attachment, that's typically where we're going to do our grounding and bonding, but I just need to make sure that I discuss how to ground the optimizers clearly and effectively. Then we're going to talk about the series connections. It's basically plugging our MC4 connectors together. I'm going to talk about how to record your serial numbers and the best way to do that, as well as connecting the modules to the optimizer, and then in general, how to bring those DC conductors from the rooftop down to the ground. Step one of our installation workflow is going to be the mechanical attachment of the optimizer to the racking system. First thing you do when you pull a box of optimizers out on the roof and you're ready to attach them, make sure you're installing the right optimizer. It's easy to say and it is easy to do. If you have a 60 cell module, just count the blue squares on your solar module. If there's 60 of them, then you're using the P300. If there's 72 of them, then you're going to use the P400. If you're installing thin film, then we're going to use the P405. The P320 is reserved for those high efficiency modules that have an output amperage of higher than 10 amps. So look at the sticker on the back of the module. If it says 10.1 amps, then use the P320. First, we're going to mount our racking system, and then we're going to attach the optimizer to the rail of the racking system. So the optimizer has a mounting hole or slot, whatever you want to call it. It is designed for 1/4 inch or 5/16 inch hardware. So to determine the location of each optimizer, I'm going to take my module, and if my module is 3 feet wide, I'm going to go in 1.5 feet on my rail and then mark a spot every 3 feet. So that way I know the location of each optimizer. The optimizer is a NEMA 6 device, so it can be mounted in any orientation. It's always a good idea to make sure we have a 1 inch of cooling clearance on all sides of the optimizer. So if you're putting a module directly over the top of it, just be careful that you're not hitting the J box of the module with the optimizer. It's always a good idea just to make sure that optimizer is pointed face down so the label is up. That way, also when you're recording your serial numbers, it's easy to grab those stickers. If you're choosing to use one of those rail-less racking systems where the module acts as the rail itself, most manufacturers have a clamp or an accessory bracket that allows you to attach the optimizer directly to the frame of the module. This also acts as your grounding and bonding device. There's a couple of module manufacturers such as Axitec, JA, Canadian, and Yingli that have taken our optimizer and embedded it into the J-box of the module, creating this smart module. I encourage you to check it out. Basically, the mechanical attachment step 1 and grounding step 2 are the same process. Solaredge offers 3 ways to ground the optimizer. We're going to go through each type in a minute, but at a glance, we have a star washer, which is shipped with the optimizer. We have our grounding plate, which can be used up to 100 times. It's got its own line item and needs to be purchased separately, as well as a grounding lug, and that requires a separate purchase as well. Very simply, to use the star washer, we're going to take our mounting bolt and we're going to slide the star washer onto the bolt so it is located in between the racking system and the optimizer itself. So the purpose of the star washer is to cut through the anodization of the aluminum, creating an effective bond to ground. So if that star washer isn't making contact with the rail, then guess what? It's not bonded to the rail. So if you have a wide channel rail, then you're going to need the grounding plate. The grounding plate is installed the exact same way. We want to make sure that our mounting bolt is secured to the rail. We have our grounding plate that is installed in between the rail and the optimizer. There's teeth on that grounding plate that bite into the anodization of the aluminum, again, creating an effective bond to ground. If you're not using the star washer or the grounding plate, then you can use a grounding lug. Some utilities and AHJ still require the use of copper wire to ground all the modules, the optimizers, and the racking to one another. So that's what the grounding lug is for. The rule of thumb, whatever you're using to ground your module can be used to ground your optimizer. So once we've mounted our optimizer, created effective bond to ground, now we're going to proceed to step 3, which is making our series connections. There are 4 conductors coming out of the optimizer. The 2 long ones is how we're going to wire our optimizers in series. So we're going to just take our MC4 connectors and then connect them together, male to female. It is almost impossible to mess up. Just of note, don't cut or modify these connectors in any way. The 2 shorter leads, that's what we're going to use for our module connection, but that'll be discussed later in this presentation. As we can see here, these optimizers have been connected in series circuits, they have been mounted, and it's easy for an installer to trace that path and make sure that they have the correct number of optimizers in series. Just real fast, you can connect up to 5,250 watts of modules per string. So if I have a 250 watt module, I can put 21 modules in series, meaning I can have 21 optimizers in series. This is also a good time to make sure that your cable management is being performed, and you can tuck all those conductors up and make sure that they're not hanging on the roof. If you're building jumpers, we need to make sure that we're using type PV wire or PV cable, it should say it, on the jacket of the conductor. A good jumper should be able to plug into itself, so it has 1 male and 1 female connector. So just like an extension cord, you should be able to plug into itself. That way we don't mix up our polarity if we have to move from one section of the roof to another in the same string. So here's an example where we have a site plan. There are 26 modules, so I'm going to be required to have 2 strings. New installers of Solaredge may be unfamiliar with how to make a series circuit, but basically we're making a loop. So positive, negative, by the time we're done with 1 string, we should have 2 conductors coming out, 1 red and 1 black. I could have done any string configuration that I wanted to. The reason I chose a string of 10 and a string of 16 is just because of the way the modules are oriented on the roof. As you can see, I have some landscape and some portrait, and it was easy to mix those into 1 string, and then my bottom row is a completely separate string, easy to do, especially if I have to cross that roof vent, and I can bridge that gap, making a jumper. Now that all the optimizers are mounted in place, it's time to move on to step 4, which is recording serial numbers. So recording serial numbers is very important so I can capture that module level data. There's a couple of ways to do it. First, and the easiest, is peeling off the QR codes of the optimizer and then sticking them to a sheet. I like to stick them to my CAD drawing so I know the physical location of each optimizer, and it's something that's already been created for me. If I didn't want to peel off QR codes, then Solaredge has got you covered. We have a couple of smartphone apps, one on the iPhone store, the other in Android. Basically, you're going to use the camera of your phone and scan each code and build the map using your phone. Once all of the physical locations of the optimizers have been recorded using the QR codes, we're going to move on to step 5, which is connecting modules to the optimizers. We're just going to grab the electrical conductors coming out of the J-box of the module and then plug them into the short leads of the optimizer. This step is impossible to screw up, and if you manage to do that, don't worry, the optimizer has reverse current protection. These modules in the series circuit or that are connected to the optimizers can have different number of modules in a string. They can be faced different orientations or azimuths, and they can actually be different wattages. So if you have a 250 that you got on clearance right next to your 275, that's okay to do. As we're laying down our modules, it's always a good idea to check your voltage at the home run. So every module we connect, I'm expecting my voltage, my VOC, to raise 1 volt per module. In this example, you can see that I have 8 optimizers in series that are connected to my optimizers, so my voltmeter should read 8 volts plus or minus about 0.1 VDC. The last and 6th step in the installation process, we're going to bring our DC conductors from the rooftop down to the ground where the inverter is mounted. Now, to transition from the optimizers to a J-box, you need to make a whip. So we're just going to take a conductor, and on one side of it, we're going to crimp our MC4 connector, and then we're going to use a cord grip or conduit to enter a J-box. So when you're making a splice in a J-box, there's a couple of approved methods. I personally like the Burndy or Polaris lugs. Make sure you get the blue ones that are NEMA 3R and suitable for the environment that you're installing them. Wire nuts are acceptable if they're rated for DC energy. Don't use AC wire nuts exclusively. Many installation companies don't wish to go through the domicile or in the homeowner's attic. They want to keep everything exterior because it's just easier to do and takes less time. But if you do decide to run your conductors through the house, make sure you're in a metallic raceway. Depending on your jurisdiction, they may be on 2008 code, which specifically says conduit. Most people use either EMT, FMC, or metal clad cable for this method. If you're choosing to use metal clad cable or armored cable, just make sure it doesn't have any white conductors in it, for that is not code compliant. We've finished our roof work, so now it's time to get on the ground and install that Solaredge inverter. We'll cover that in our next video, the installation ground crew. Thank you for joining me today. If you have any questions, please feel free to reach out to us, attend a webinar, or watch one of our how-to videos.